All right, mic check 1 2. Welcome to Fun Times. We're gonna keep doing the Automate Your Network series.
All right, welcome back to back.
So look, oh great! So I got 2 likes. That's that's good for my videos. So okay, so lots of popular demand for this series. So we're gonna keep going. Now we were on um chapter 6, but that's just kind of a placeholder. We're not really on chapter 6. We're just okay, and it looks like I have to get this working. So here we go. Automate your network. And that's the folder. Perfect. Okay, so we're not really on chapter 6. We're just kind of getting it to the state it has to be in before we can do the things in chapter 6. So like, yeah, this is a part of chapter 6 because as soon as I get the network to the state it needs to be in, I will be doing the things in chapter 6. And I finished reading all of chapter 5. So we're in chapter 6, but technically this is kind of a subsection outside of the book where I'm just getting the network to the state it needs to be in before we can do what's in the book. And unfortunately, I kind of do have some disappointments with this book that I really can't give it a 10 out of 10. I will give it a high score though. It's so far been great, and it delivers on what it promises. But I think when it comes to automation, there's really kind of an under promising happening that it's hard to realize what is even being promised if you're not already a network expert. So if you're not already a network expert, you might hear automation and you might think all the problems in your network are going to be solved. But the more you know, the more you just kind of see, to some extent, the emperor has no clothes when it comes to automation, because when you deliver new devices, they have features on them called ZTP, zero touch provisioning, and if you're not taught about that, if you're not taught that that's a thing and taught how to set it up, your provisioning starts once your network is already up and running. And the automation starts at a presupposed state of the network where there's basically not much need for automation anymore because it's already up and running. So like, yeah, you need to automate the daily maintenance, monitoring, addition of new services, rerouting of traffic, all this stuff, yes, needs to be automated. But when it comes to the project management of a network, that's going to constitute a very minuscule part. Um, in my experience, what really matters when it comes to networking is building out the devices of your network, setting them up, making sure they have power, cable them together, putting on initial configurations, updating configurations. Yes, is important. Making changes to a live network, yes, occurs every day as part of what network engineers do. But to say automation is this big thing because it makes it so that 5% of our duties are now done, you know, in a little bit faster. It's like, well, that's kind of a criticism I would have. And I thought, oh, right. So this was, and we talked about that with the AI. There was a conversation where we actually pulled out from it all of the strategies you could do to bring a network to the state you needed it to be in order to implement the automation discussed in this book. And one of those strategies was what I wanted to get going in my lab, which is setting up ZTP. A lot of devices will come with ZTP. Aruba's got really good ZTP. So I have some Arubas in my lab. Aruba ZTP is zero touch provisioning. So uh, yeah, so this book, Automate Your Network, is if we think of it as a relay race, it's starting, it's at like the end of the race. It's not like ZTP would come before anything discussed in the book, which is unfortunate because um, that's the stuff that um, is hard. That's the hard stuff. So yeah, so we need to get ZTP working in the lab. There's a number of ways we could do that. We do need an out of band management network. Just generally, that's good. Generally, that's good practice to have. So we did set that up, and then we went through in a prior video and actually picked out some real gear that we could use for that. I think it's here. Yeah. So we looked at what you could use for the jump host and for the server. You could the DHCP server. You don't need anything too fancy. So like this, save some money in there. Like, looks pretty good. And then we looked at the network switches that you would use. So not that expensive, especially in the grand scheme of a standing up a network. Okay, and then where we left off is we're trying to get a DHCP server up and running, and we're trying to assign out of band IPs to each device on the network. So we had to pull out the server that was there and put in a new one because it's just more convenient to use this one because all the networking stuff happens more seamlessly. So I think that's where I was at. I don't remember exactly. And we can go back and kind of review where I left off. I thought there was like some tedious thing I was doing where I'd have to do like some stuff in between videos. All right, so we got to wait for this to come up. Oh, here we go. Okay. There we go. Looks good to me. And yeah, we're simulating a network that kind of won't exist in the wild. You will have definitely some wired connections. You might have phones too. We don't have here for if these are all desks in a a slice of heaven on earth, a standard office building. They would probably have incessantly ringing IP phones as well. They could have them like maybe virtualized or something, but that's one component we're missing. Another major component we're missing is the Wi-Fi. You would definitely have that if they're all on laptops and they wanted to move back and forth through a conference room or something. You have to have Wi-Fi, and then for like a guest lobby, you would have Wi-Fi. So that's a huge component. Another kind of unrealistic component in this network is the data center. Having a data center just in your building on premise kind of seems like a lot. It just seems a lot to manage. It seems a lot that you have to get right. So especially depending on how this grows or like how many users there are or what they're actually trying to do in this building. This I don't think is very typical. I think often you'll see this in like a colo, because if it's on the premise like this, you straight up need a electrical engineer to design how power gets to all these devices. It's not just like plugging them into an outlet at this point. It's like, no, you can't just plug all of this into an outlet. You have to have a designed electricity scheme for like a data center. And if you go to a colo, they already have that like designed. So like this would probably be in a colo a lot of the time, but you could even have this like in the cloud. So like there's a lot of components here that aren't exactly accurate. On the floors you would have IP phones, and you would definitely have like Wi-Fi. In the data center, you probably wouldn't have this here at all. You'd have it go off to a remote co-location, or you'd have some kind of cloud service that negated your need for the things that were happening here. You'd still have the core section, probably look the same. Um, you'd still have internet access with firewalls, and you'd still have this is where it gets tricky as well, because you probably have some kind of SD-WAN system if you needed WAN. So yeah, it's really kind of not the best representation of the real world, but the goal is just to learn about like Ansible and stuff for now and make it through this book. We're actually more than halfway through it, so it's good enough for now. Maybe at some other point I can build it out, but let's see if I've got internet access. We can use 1.1.1.1 because it's been reallocated um, to Cloudflare. Okay, so I don't have internet access. All right, no internet access there, which is strange because I do have internet access on this machine. So I don't know if it just can't do it on multiple machines, or like what the deal is. Um, I mean, we can try asking the AI. Let's try that. That's always a good place to go. So here's the deal. I'm in GNS3 and I have a cloud dropped where I can access internet through. I have one server connected to it that has internet perfectly fine, and then I have 3 extra interfaces added to the cloud, and I have 2 exit points from my network that I am virtualizing connected to the cloud, and then I have one more device which will act as my server connected to the cloud, and I need it to have internet briefly so that I can set it up with like DHCP and DNS services and etc. So the thing is, like, I'm not getting internet to this. I can only get it to this one device. How can I configure the cloud icon in GNS so that it can serve internet to multiple devices connected to it?
In GNS3, the cloud symbol is used to represent a connection to an external network, such as your physical computer's network interface, which can provide internet access to the devices in your virtual network. If you are facing issues with providing internet access to multiple devices through the cloud in GNS3, here are a few steps you can follow to troubleshoot and configure the setup. Check IP configuration. Ensure that all devices connected to the cloud have the correct IP configuration, including IP address, subnet mask, and default gateway. The default gateway should be set to the IP address of the interface on the cloud that is connected to the external network. Configure NAT on host machine. If the cloud is connected to your host machine's network interface, make sure that network address translation, NAT, is enabled on the host machine to allow multiple devices to share the internet connection. Use router. Consider connecting a virtual router between the cloud and the devices in your GNS3 topology. Configure the router with NAT pad to allow multiple internal devices to access the internet through a single external IP address. Check firewall settings. Check the firewall settings on your host machine to ensure that it is not blocking traffic from the virtual devices in GNS3. Review cloud configuration. Open the cloud configuration in GNS3 and review the settings. Ensure that the correct network interface is selected and that it has connectivity to the internet. Test connectivity. After making the necessary configurations, test internet connectivity from each device. Use tools like Ping and Traceroute to troubleshoot connectivity issues. Review DHCP and DNS settings. If you are setting up DHCP and DNS services on a server, ensure that the server has the correct configuration to provide IP addresses and resolve domain names for the connected devices. Remember to save your GNS3 project and configuration changes as you make them. If you continue to experience issues, you may want to refer to the GNS3 documentation or community forums for additional support and troubleshooting tips.
Alright, so it's just saying to do basic network troubleshooting, which is what I'm doing. And yeah, it's just having trouble. It's just having trouble. I mean, honestly, what I could do is just like disable it, or sorry, I mean like it doesn't have to be this machine, or like so like I can unplug this one and then see if that changes it. Like what I mean is like it doesn't have to be the case. Oh, and it looks like I did something I absolutely did not want to do. Um, which is like how with GNS, you always have to make sure that you click somewhere so you're not accidentally selecting multiple things that you don't want to select. Like that's one of the biggest problems with GNS3 in my opinion. It's far too easy to make accidental selections of things. I have used Eve NG. It might be better, especially in that regard, but there's like I don't know. GNS is fine. I was actually using Eve for a while, like more than GNS. Uh, all right, so yeah, everything looks better. So I accidentally deleted my other server, which is bad. I needed that, but hopefully this one has access now, and I can just set it up and then be on my merry way. And just yeah, I bye bye server. I needed you so bad. Okay, yeah. So it looks like the first one is the only one that has live internet for some reason. Hopefully that's not going to be a problem. But I need to pause. I'll be right back. All right, I'm back. So let's keep going on this. Now that we've got internet, and we might have to figure this out later because it is going to be a problem that these two devices here can't connect to the internet. But what we could do is we could have just multiple clouds here, one for each of these, and one for because it's the internet. So like we can have it connect out like that or like that. You know, it's about like dual home, multi home, those kinds of things. So like, uh, it doesn't have to connect into this one cloud like that there. All right, so here we go. So the next step we're gonna do is get the DHCP server set up, and it should be I think in a GNS converse or sorry a Chat GPT conversation that I had. I think all the steps of what I needed to do are in that. So this might even be it. Right? Oh no, sorry. I forget what it was. I think this was probably it. Yeah, this is like a super long one, so I think this was it. So I mean, we can start a new conversation, but let me just search for ZTP. Okay, so we do have a match for ZTP. It's over here. Okay, so yeah, this is what it's kind of a smaller one, but I think this is the one I'm looking for. Yeah, so run me a guide for configuring ZTP for new devices on my network. So yeah, this is it. This might be it as well. I just want to find the conversation for yeah, so I think this is it. So So yeah, this is it exactly. So this is it. This is exactly what I need. So in order to use network automation tools like Ansible, the devices need to have network connectivity and should be reachable over the network. This means an initial configuration, setting up management IP addresses, needs to be done manually or through some other means before you can automate further configurations or management tasks using Ansible or similar tools. And therein lies the rub. You're hired to be an automation expert, and there's no network to automate. So you're expected to automate a network that doesn't exist. How do you do that? Well, here's some ways. The first way could be zero-touch provisioning. Many modern network devices support zero-touch provisioning. With ZTP, devices are configured automatically when they are powered on for the first time. A DHCP server provides the network information and the location of the configuration file, which the device downloads and applies. The second way could be pre-staging configurations. This is the way I've done. If ZTP is not an option, you can pre-stage the configuration by giving a base configuration, including management IP manually, or using a console connection before deploying the device to the network. So that's the way I'm familiar with. So I'm excited to learn a new method. The third method is DHCP and dynamic DNS. If the devices can obtain an IP address via DHCP and register with dynamic DNS, you could potentially reach them using their DNS names to perform the initial configuration. So I think that's the one I'm going to try out in my lab. The fourth way is console servers. Some organizations use console servers that provide out of band OOB management access to the network devices. This allows remote access to the device console port for initial configuration before IP connectivity is established. So this is a good point here. This network I have, it's technically in band still because it's like connecting to, well, in band and out of band are weird, are kind of confusing terms sometimes, and they're easy to conflate. So it's out of band, but band of what? Band of where your live traffic, your customer traffic. That's what the band is. So it's out of band. It's not in the same links as the customer traffic, but it's not connecting to the console port. The devices are designed to have out of band management come in through special management ports using IP, but also through the console ports. So like when you have a console server, you don't need an IP addressing scheme in that case because it's in through the console port through serial. But we're not doing that. We do need an IP addressing scheme in our case. So that's another thing you can consider, like out in the real world, is having a dedicated device. Like a lot of times you can have like a tech shows up and they plug their laptop into the console server. Like, I've experienced into the console port, and they use their laptop as a console server. I've experienced that as well. And the final thing you could do is some devices support loading the initial configuration from a USB drive. This can be used to load the base configuration, including management IP, username, and password, to enable remote access for further automation. So, so these are the big ones. This one is probably best if you can set it to if you can make sure it's set to draw a DHCP address. But I'm going to try this one in the lab number 3. So I really like the third option, DHCP and dynamic DNS. Please explain this more and explain how I can apply it to my lab. Step 1, set up a DHCP server. So that's what we're doing. Okay. Yeah, so ZTP is like its own thing. It's kind of It's kind of like an IP phone. You know how an IP phone gets a config. You know, it's like that. So let's try to get it working here. Okay, so let me start a new chat, and we're gonna load it up with this. Let's turn the prompts off because one of them could be triggered and fail out the conversation. So, okay, so please walk me through step one.
Certainly. Let's break down step 1 in more detail. Step 1. Set up a DHCP server 1. 1. Add a DHCP server to your GNS3 topology. Open GNS3. Choose router with DHCP capabilities or a dedicated DHCP server appliance like DNSMask or ISC DHCP server. Drag the chosen device to the workspace to add it to your topology. Connect this server to the network where your devices reside using the connection tool. 1. To configure the DHCP server. Once you have added the DHCP server, router to your topology and connected it to your network, you'll need to configure it. Here's how you might do that for a Cisco router. Access the router CLI, right-click on the router icon. Click on Start if it's not already started. Open the console. Enter configuration mode shell copy code enable configure terminal, define a DHCP pool shell copy code if DHCP pool lab underscore pool assign network details, set the network and subnet mask.
Okay, so we do have some pre-built machines here. Um, so here's one for DNS. I don't see one for DHCP. But let's use this one here for DNS. So we're going to do an install. There we go. Alright, so that's for DNS. You know what? That's too tricky. Let's just go with this one. Okay. Yeah, we could do it. We could do it on a. I'm almost tempted to do it that way because that's just really nice. But we do want the boot file to be delivered. I mean, we could have it in two different locations. We could have like a redundant DHCP server. But we could have like a DHCP server on one of these Cisco devices. That's pretty easy to set up. Probably not the one in front of our firewalls. So yeah, let's set it up on WAN Access 01. Okay, so for some reason there's no interfaces. I don't know what's going on there. Yeah, this is just a regular Cisco image, so it should have interfaces. It does have interfaces. This one doesn't have any interfaces either. Um, yeah, it just doesn't have any interfaces. Huh, okay. Um, all right, I wasn't expecting that. Uh, these have interfaces? No, those don't have interfaces either. All right, well, that's a problem. All right, that has lots of interfaces. So we might have to swap out these down here for ones that actually have interfaces. Not sure what's going on there. Let me try dropping a new one. All right, booting that up.
Setting up. A DHCP server on a Bionic Ubuntu server 18.04 LTS can be accomplished using the ISC DHCP server package. Here's a step-by-step guide. Step 1. Install the DHCP server package. Open a terminal on your Ubuntu server and run the following command to install the ISC DHCP server package. Step 2. Configure the DHCP server. Once the installation is complete, you'll need to configure the DHCP server by editing the etc. DHCP, DHCPD. Conference file. Use a text editor like Nano to edit this file. Here's a basic configuration example. Adjust the values according to your network requirements. In this example, the DHCP server will serve IP addresses in the range 192, 168, 1, 10 to 192, 168, 1, 100. The subnet mask is 255, 255, 255, 0. The default gateway router is 192, 168, 1, 1. Save the file and exit the editor. For Nano, press Ctrl+X, press Y, then press Enter. Step 3. Define the interface. Define on which network interface the DHCP server should be active. Edit the, etc. default ISC DHCP server file. Locate the interface SD4 line and set it to the interface you want to use, for example at 0. Save and close the file. Step 4. Start the DHCP server. Now that you have configured the DHCP server, start the service and enable it to start at boot. Step 5. Verify the DHCP server status. Check the status of the DHCP server to ensure it is running correctly. If everything is configured correctly, you should see that the service is active and running. Step 6. Adjust firewall settings. If you have a firewall enabled on your Ubuntu server, you'll need to adjust the settings to allow DHCP traffic. For UFW, you can do this with the following commands. Step 7. Test DHCP server. Connect a client device to the network and configure it to obtain an IP address automatically. Check whether it receives the correct IP address, subnet mask, and default gateway. With these steps, you should have a functional DHCP server running on your Ubuntu Bionic server. Make sure to adjust the configuration settings according to your specific network requirements and topology.
All right, so in the meantime there, I was testing out if I can drop a new one of these and get the interfaces. I can. So at some point I will need to swap out these for ones that actually have functional interfaces. Um, right now, I should be fine. I just need to get this operating uh, as a DHCP server, and then I can plug it in like to the core. And if it feeds out DHCP to everything, then hey, we're good to go. All right, so I need to follow the steps given to me in the AI, and I can figure out how to do it without the AI, but this is just easier. Oh man. Okay, so once the installation is complete, we'll need to configure the server. All right, installation's complete. So here's a basic configuration example. Adjust the values according to your network requirements. So we need to define the domain name. I'm going to change it from example.org to techyes.com. Okay. And then yeah. So let's change the names of the name servers as well. All right, and then lease times, Mac lease time. That's probably fine. Um, then we need to define the DNS server. It's probably just going to be this one here. I don't see where that exists already. So maybe I'll just need to add it myself. Okay. Yeah, I don't see anything about defining the Oh, I guess this line is what does it? Yeah, it says option domain name servers. Okay. So, okay, fine. Um okay, so there's more settings. Okay, so next define the network. There's a lot of pre settings in here. So I guess I'll just put it at the bottom here. Define the network. And now I'm pretty sure I have all this. So the subnet for my OOB is down here, 10.0.0.0/16. Oops, I can't do that. So 10.0.0.0 net mask 55.255.0.0. Okay. Range 8.1.10, 192.168.1.100. Oops, we gotta have the range be correct. Okay, and we'll do it in the range dot 1 through 0. And then 10.0.255.254. So we got all kinds of addresses. Don't have to worry about it running out. And in fact, we've got the whole .0 space as well, 0 through 255. So we should probably have it because we got .0 through 255, and then we've also got .1 through 255. Okay, yeah, so we're just gonna reserve a few addresses, like 254 addresses or so. And then the rest of them, which is a lot of addresses, will be free to be given out. So it's kind of overkill. Probably a bad design choice, but that's okay for now. So default gateway will be here. And yeah. Alright, looks good to me. Yep, so range is there to there. Oh, looks like routers with an S. And yep, looks good. All right, looks good to me. So then I think we need to do a restart of the restart of it. So okay, so we need to go back into it. Oh, to a different file. Okay, and then we need to put in the interface that it comes out of. So it's an IPv4 interface, and I'm pretty sure it's it's ENS3, but we can put it on anyone because it's not going to be connected where it's connected now. Okay, looks good to me. And then we'll save and exit the file. Okay, and now we start the server. So let's move this to where it belongs now. So we're gonna exit out of the configuration for it. Open this. Then we will delete that. Oops, and I forgot to do my safety click. Always do a safety click when you're in GNS because otherwise you can blow everything away. Okay, but now there we go. That's ENS3 into here. We'll do a safety click and then open this up. Oh, sorry, we got to go to the console. We can double click on it to get to the console. There we go. And now let's do the final sections. So step 4 will be to start it. Okay. And now that it's started, we're going to enable it. We just started the daemon, but we didn't turn the daemon on. Okay, so now we're going to verify it with systemctl. Oops, and looks like it failed. That's a problem. That's not good. Why did it fail? Oh man, I really wish I could. I mean, I can paste it in. Exit code. Submitting a blog. Failure? Why did it fail? I don't understand why it failed. I'm really confused as to why it failed. Okay. Let me see if I can get. Why did it fail? Let me sniff the link. I just want to see if it truly failed. Because if we see DHCP, now we see DHCP, but which MAC address does it come from? So it comes from 00. So it comes from 0C3B. Uh, yeah. So what device is that? Oh, yeah. See, this is what I mean. So it's coming from 0C3B7993. So 0C3B. Oh, 7993. So yeah, it's coming from somewhere. But these are discovers. I mean, we should have discovers coming from every device on the network. So that's normal. Oh, but here's where it gets interesting. We actually have a request. Oh, yeah, so we have a discover, offer, acknowledge request. What is this from? So it's from it's still from that 7.9 device. Huh. Now is there a way to see if this is received or transmitted, or like the direction this is going? Because what I want to know is I mean, obviously we know if it's not sourced from here, then it's going to be, it's just flooded. It's just flooded everywhere. So uh okay. Well, I'm confused here. I just wasn't expecting the DHCP server to fail. So I guess we'll try it again. Failed. Let's try going to ChatGPT here. Oh, right. I've gotta change it. Okay, safety click. Stop capture. Safety click. Delete. There we go. And now we should be able to get to ChatGPT. All right. Well, I definitely clicked on the login button. Nothing's really happening though. It's not on my end. Okay. Yeah, there's some kind of issue. Um it can't log me in. Alright, I'm just trying Chrome because I'm having an issue with Firefox not responding. Everything's slow because it's virtualized. Wonder what a speed test. What I get for a speed test. It's probably not that bad because it's mostly like the legginess of my mouse clicking. Like it's just like another. I mean, maybe something with the like virtualization overhead or whatever. I don't know. Maybe like I'm virtualizing a network interface card that is like not as good. Okay, so let's try ChatGPT from here. All right, that looks better. It actually, yeah. Okay, now we're in business. So I'll move this away, move this up, and do yep. So that's in favorites. So we're gonna remove this one from favorites. Okay, and okay. So yeah, speed is not bad. I'm in the United States, so that's not bad for us. I think I gotta do two factor. So I'm not sure if my phone is by me. I hope it is. Yeah, I gotta do two factor. Dang it. Uh, oh, it's right here. All right, not bad. It was not that hard. Okay, so now we're about got the same thing. We can dump in our error. All right, so they gave us technical support. That's probably it. Is permissions. So, oh, it's still generating. It's really got a lot to say about that. All right, so step one, there we go. Step two is to check the interface. Uh, okay. Now we do it with the interface up, but we're doing it with the wrong with the interface plugged into the wrong thing right now. But let's just do everything that that's asking for. And I'll bring it up to speed if necessary. It's so good. Yeah, maybe I made an error in the file. That's probably it. Okay, yeah, so it says it's fine. Huh. So why is it not coming up? Okay. So if the file is fine, then why won't it come up? Oh, we can do a -T to check it. I mean, it looks like it's fine, right? It's not doing anything. So we can review the logs now. Don't see anything in there. Check the status. So, I mean, here it is. Um, so maybe when I set the um, so it says ENS3, so maybe it's ENS03. Nope. I set it to ENS3. Um, so maybe this has to be 2, like the number 2 that's listed here. Should be right. All right, let's check the file, the permissions of this. So read, write. Um, yeah, looks good to me, right? Uh, nothing. Yeah, I don't know what the problem is. It just won't start. Okay. Well, I mean, I guess let's try the built-in one then. Oh, we can do. We do. Do we have? We do have like a wireless LAN controller here, and then SD WAN. Some of these images aren't easy to get though. So here's a networker's toolbox. Maybe that has DNS and all that in there. Let's try that. Oh, okay. So we actually already have it. So let's try it. Yeah, here it is. Okay, here we go. So yeah, it looks like we do have DHCP up and well in here. So we've got the config file is here, database file is there. So yeah, let's go with this for the machine. So I'm going to relabel it to match here, and then this will be the jump host. So I will do a change host name. I'll do a control X, and I'll call this jump host. Okay, and then I will do a change host name on this, and then this will be serving that purpose. Oh, actually, that's the jump host there. So this will just be like a uh, let's call it like IT admin. We'll call it like admin because this is like somebody working remotely on the network. Okay, so yeah, this looks good. So let's cable it up. All right, and then get into this machine. This is the admin host, so we can close it. This is the host we want to work with. All right, so here we go. Yep, so we got to edit this file. Let's do it. Okay, looks good to me. Then we need to change. Oh, we need to add the IP. So if this breaks it, then we know there's a problem. That might have been what was going wrong. Yeah, I probably forgot a. Yeah, I probably wasn't doing this right. I mean, we can see the example up there, and if it doesn't match, then yeah, that was the problem. Yeah, so like here's examples. So yeah, that looks good. The range looks good. Option domain name. So like the domain name servers, they don't really have an IP. Option routers looks good to me. All right, so yeah, this is good. Okay, so next one is nano Etsy default server. Okay, and then we'll put ENS3. Or well, let's put what it is. I don't know what it is, so we're gonna look that up. ETH0. Okay. And then let's restart the server. And the good thing about using this too is I can copy between the two. I can share a clipboard with this. Oh, we don't have sudo. Okay. Oops. Okay.
It seems like the system you are using does not recognize sudo and systemcdl commands, which are typically available on systems using system, such as Ubuntu and CentOS. If systemcdl is not available, your system might be using another init system like SizeVinit or OpenRC. Below are alternate ways to restart the DHCP server depending on the init system. For SizeVinit, or for OpenRC, check the init system. If you are unsure which init system is in use, you can try to identify it using the following command. The output will show which init system is running as the first process, PID1. After restarting the service using the appropriate command, you can check for error messages in the log files, var, log, syslog, or var, log messages to find more information about any issues that might be preventing the DHCP server from starting successfully.
Alright, so I'm not sure how to find it there, but I was able to restart it here. So let's take a look at the traffic. Okay, so we've got our discover messages still, but I don't think we have any responses. Lots of CDP traffic. Any broadcast traffic we're going to see. Okay, so let's try a... So we did a restart. We did a service restart. Let's do a service start on it. Alright, so we're starting it. There we go. It should be started. So hopefully we should have some replies to these. Or some offers being sent. Nope, all we got are our discovers. Huh, okay. Well, that's too bad. Why is it not working? Uh... Oh, it's not running. No subnet declaration. So you have to write a subnet declaration. Oh, you know what? I think I have to configure oh, ETH0, ETH0. Hey, we got it. Okay, so we should start to see these populate now. There we go. See, now we've got these offers, offer. So we got 2 devices are good, 3, 4, 5. It's really the acts that matter. So let's do DHCP dot ACK. Or let's do one of these acts. Then we go to DHCP. We look for the actual ACK. So Uh, so it's probably in the uh it's right here in the message type. So now what we can do is right click on this and say apply as filter. And then the selected filter we have. So dhcp dot option equals 5. There we go. And now all we see are the acts, which will help us determine if every device has got a IP or not. So here's all the IPs that were given out. Oh, we got 14 is there twice. All right, so there we go. We do have some like showing up twice. I'm not sure what's good. Oh, you know what? I think the axe will I think the axe will show up twice. I think the ones we actually wanted were the requests, because the requests won't show up. Won't just continue. So let's search by the request instead. Okay, so that's option 3. Oh, you know what? We're still getting requests, and not only that, we're getting only broadcast when we do that. We want to see the unicast. But now we're not getting anything when I do that, which is weird. So there's the offer. There's so discover offer request, and then I thought 4 was acknowledge, but it looks like 5 is acknowledge. And then yeah, that's so I'm not sure what happened to 4. But here's all the acknowledge. So yeah, we've got we could check the leases file to see what we got. So let's do that. Okay, so now we've got leases, so we can do pipe grep lease. Okay, so now there's our leases. So now we can do a pipe WC. And we've got 18 leases. Let's see how many devices we've got on our network. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So we are missing quite a few. I don't know if it just hasn't gotten it yet. Nope, I think 18's the best we're going to be able to do right now. Oh, there we go. We got 19. We need 22, though. I mean, I think we're going to be missing 4 because these had the problem with the interfaces. But that would mean 18. So I guess it could have been these. I'm tempted to just swap those out right now. But anyways, yeah, so we've got actual um connectivity in a way there. So now I can SSH to some of these. Actually, SSH I think needs to be set up to them. Uh, oh, that's interesting. No route to host. I wasn't expecting to see that. Well, it's got a route to the host right there. All right, not sure what's going on with that. We do have IP addresses now on a lot of our devices. Oh, now we've got 25. How does that work? Okay, so did these get IPs somehow? Alright, well, I'm not sure how to log into those right now. Yes, we'll close that session. Okay, so I did get the IPs on there. So, but what we're trying to do is we're trying to start gathering information about the network. So we want to run an Ansible playbook against these. So we've got to set up some sort of management uh, method, some sort of method of accessing these. Um, and I deleted my my server that I was using. All right, I gotta set up VS Code, so I'll take a break while this is going. I'll be right back. All right, I'm back. Let's just keep going. I'm gonna definitely end it at the 2 hour mark. So, uh, let's just keep going on this. So I've got this set up. Yes, I trust all the authors. So I need to download my what I've been doing for TFS again. So let's go to let's go to the Azure server. Yeah, the Azure DevOps server that I had, and we have that in the notes. So let's open up Visual Studio here. It looks like it's already open, and then let's go to the notes that I've been taking, which is right here, book. Okay, and then we'll go to the TFS there, and we'll have to upload a new key and everything because I accidentally blasted away my server that I was using, which is really annoying. All right. Oh, I have to log in using my Microsoft account, which is very secure. There's a lot of advanced, sophisticated security that goes into this. It's kind of a joke. There's a video on some really concerning mishaps with Microsoft when it comes to security. I guess they were like they were promising that they were going to use tokens that automatically expire, but the uh, but the tokens would like they didn't set up the mechanism that they said they would use or something. So like there were these like forever tokens out there that like people would log in with. It's like if they had done the thing, then it would have worked out great. But they didn't do the thing. Um, so something's happening here. Maybe I'm on the main branch. No, that looks good. Uh, that was 2 weeks ago. Where's all my stuff? Maybe I changed all this. Oh, it's up to date. Oh, okay. Yeah, so I need to update the book read through notes. There we go. All right, so TFS link correct in readme but not book notes. All right, looks good to me. All right, let's get this going. So we go to the repo. And then we'll do a clone. And we'll do it through generate git credentials. Oh. Uh okay. Now it should ask me for a password. It does, and I have the password right here. And it's just a temporary password too, so it doesn't even matter that it's in this video because it won't exist unless it's the problem with uh it as I mentioned earlier. I watched a video on that recently. All right, looks great. Okay, so now we got what we're working on for actually like configuring or for like doing this part. And then if we go and look at the TFS server, um, which I do have up here. That's one way we can look at it. Yeah, and we go to the board. Okay, so we've got this epic in there. So then the first thing we're doing is enabling SSH access. So, yeah, unfortunately, it's kind of as clever as I thought I could get, just pushing out DHCP addresses, and it worked for the most part. They all have DHCP addresses. The thing is, we have to set up DHCP, or sorry, SSH, and you have to go in through console. Console is king. All right, so let's start here, and then the goal is to get SSH access from this device, and then once we have that, we can plug in like our admin device there. Plug in this device just anywhere. Yeah, so we can plug it, have this device be here, have the admin device be here. Whatever. I'm just overcomplicating it. The point is to read through this book, so I'm just trying to get too fancy and as such going kind of beyond. Because the thing is, like, when you get on the job, and this is important, like, I mean, you do what the job tells you to. Like, you know, that, like, get your CCIE, yes, like, learn the fundamentals, but like, never go to the job with this kind of idea or attitude that everything I've trained for in my life qualifies me to do this job, and therefore this is how I do the job. It's like, no, like, you do the job depending on the requirements of the job. So like, you're not going to learn anything specific about what you need to do to accomplish the job until you're on the job. So like, you can't assume that, oh, I've got this ZTP set up like this, therefore it's going to work exactly the same once I get to the job. It's like, no, you like, especially in this case, because, you know, I'm just simulating these devices. Like, it could be a Nexus device that I don't have access to that works in a whole different way. So you have to listen to your coworkers. You have to read the documentation that is relevant to the devices you're working with. You have to open attack cases as needed, because it could even just like bugs in the OS is what's holding it back. So you can't, when it comes to being on the job and doing things on the job, great. It's nice to have done stuff like this. This stuff can be helpful. It can reinforce the fundamentals, which you can bring to any job. Knowing the fundamentals is essential, is critical, but it's not enough to do the job successfully. You need to know the context of the job. You need to know the specifics, you know, not just the fundamentals. The fundamentals will help you understand the specifics, but if you know the fundamentals, that's all you know. Like, it's not going to help you do the job. The specifics are what help you do the job, and the context. So I just wanted to be clear about that, and kind of justify in my own mind trying to simplify this. Okay, so we got to try to enable SSH access. That's what we're doing right here. So let's try that. So this is just a basic Aruba. Should be pretty easy. So SSH, and when we don't want it to be password, we want it to be through. We want it to be through. Shoot. Let me actually close this, and then let's put this on the network, and we can stop sniffing here. Okay, and then let's give this another connection here, because we want to manage from here. It should get a DHCP address. We should see it. See it come up. Okay, it looks like it is connected. So I can just do like a IPA to see. Yep. So 4 has a DHCP address. See, so that's kind of cool that you can do it that way. So it's kind of worth it just to have all the IP addressing out of the way. But unfortunately, you still do need to set up the SSH access itself. Unfortunately, that's really too bad. I mean, one thing you could do is like, no, because like external management is something that you set up. There's really not usually default external management on devices like these. But one thing we can try to do is just plug in some of the IPs we've got registered and see if there is like some kind of external management interface by default. So let's plug in the .6. I'm pretty sure you have to turn any capacity to manage a device remotely is, from what I understand, off by default. Let's go to 115. Yeah, so any capacity to manage a networking device remotely has to be explicitly enabled. Yeah, so 115 is down. Let's try a few more. Let's try 112 and 113. Okay, and then we'll try 106 and 107 next. All right, yeah. So any capacity to configure a device remotely has to be configured locally on the device, and then you can do what you will remotely. So therein lies the problem with automation from a new device on day one, unless it has some special mechanism such as ZTP. All right, I'm gonna pause. I'll be right back. All right, I'm back. I can keep working on this. So it's kind of a nightmare. It's not quite so easy to get it to that, and that's the point. You know, that's what I've been saying this whole time. Is like this book presupposes a network state that presents its own set of challenges, so much so that the solutions in this book kind of, you know, it's like putting the frosting on the cake. Like if you don't have the cake, it's going to be hard to put the frosting on it, and baking the cake is the hardest part. All right, so let's just try to enable SSH access. And let's make it easy on ourselves. We're gonna do a show version, and we're gonna copy it, and then do walk me through enabling SSH on this device. Walk me through enabling SSH on this device. Okay, we know the host name for this.
SSH and an Aruba CX switch involves generating cryptographic keys, creating a user account, and enabling the SSH server. Here are step-by-step instructions for enabling SSH on an Aruba CX device. 1. Access the CLI first. Make sure you have access to the switch's command line interface, CLI. You can access the CLI directly through the console or remotely if you have other methods enabled, such as telnet.
Console.
2. Enter configuration mode. To make changes to the configuration, you need to be in the configuration mode. Type the following command and press enter. 3. Generate cryptographic keys. SSH requires RSA or DSA keys to establish secure connections. Generate the cryptographic keys with the following command. Follow the prompts to set the key length. Typically 2048 bits is recommended. 4. Create user account. Create a user account with the appropriate privileges. Replace admin with the username you desire and set a strong password. 5. Enable SSH server. Enable the SSH server on the switch. 6. Configure SSH access. Set up the VDY lines to use the local username and password for login and enable SSH access. 7. Save configuration to ensure that your changes are retained after reboot. Save the configuration. 8. Exit configuration mode. After saving the configuration, exit the configuration mode. Now, SSH should be enabled on your Aruba OCX switch, and you should be able to access it remotely using an SSH client by entering the switch's IP address, username, and password. Note: these commands are based on a generic setup and might slightly differ based on specific versions or models of Aruba OCX switches. Please refer to the official Aruba OCX documentation for any version-specific instructions or additional configuration options.
Okay, so there should be a way to put my public key in here. Public key authentication. We might need to be careful that we're generating the right. I think it's 2048. If the sizes don't match, that could be a problem. Oh, you know what? I don't even have it. So let's go with a 2048 key. So we're gonna do RSA keygen dash help, or do keygen dash help SSH dash help. There we go. And then we'll do dash T for RSA. And then we want the size, so we're going to do dash B for, and then 2048. All right, looks good to me. So the next thing we're going to do is do that same thing over here. Yes, let's override it. Okay, and show IP interface brief. Wait, what's going on? Oh, this must be one of the devices that doesn't have a IP on it yet. Well, hold on. The management interface doesn't show up on there. Okay, so this one does have an IP. It's right here. So let's try hitting that IP. Okay, so we got it. Let's do a SSH. Okay, SSH is working. Great. Okay, perfect. So yeah, now we get to a password prompt. We don't want to do it through the password. We want to do it so we don't need passwords. So we're going to do SSH. And then password authentication. Let's do no SSH password authentication. Okay, and let's see if that changes things. There we go. Permission denied public key. So now we need to give it a host key, I think. Oh, that's a no. Okay, this is to generate the host key. We already got one. Um, all right. Okay, so let me do this. How can I disable SSH password auth and make it only accept the public SSH RSA key from my designated management server?
You are looking to disable SSH password authentication and allow only public key authentication for your SSH connections on the Aruba OCX device. Here are the steps you need to follow. 1. Disable password authentication. You already issued the command to disable password authentication. 2. Configure public key authentication. Ensure that public key authentication is enabled. It's enabled by default, but you can explicitly enable it with 3. Upload the public key. You will need to upload the public SSH RSA key from your management server to the switch. This can be done by copying the public key to the switch's authorized _keys file for the user. Use the following command to configure the public key for the user. Replace admin with the actual username and public _key with the actual public key string. 4. Verify configuration. Once the above steps are completed, verify the configuration to ensure that password authentication is disabled and public key authentication is enabled. Look for the no SSH password authentication and SSH public key authentication in the configuration output. 5. Save configuration. Finally, save your configuration to ensure the changes are retained after reboot. Testing from your management server. Try to SSH into the switch using the key pair. Password authentication should not work, and the server should only allow access using the public key. Remember to replace path to private key with the actual path to your private key and admin with the actual username. Note: ensure that the user has the proper permissions and that the public key corresponds to the private key on the management server. Make sure to test the new configuration to verify access before logging out of your current session to avoid logout. The commands might slightly vary depending on the exact Aruba OCX version, so refer to the official Aruba OCX documentation for any version-specific instructions.
All right, I'm not sure if this is it. Oh, and I have to use a. Let's see if it. Oh yeah, invalid input there. So, yeah, I think we'll have to refer to the actual. I think we'll have to refer to like the file. So like AAA might be it. AAA authentication. Login. SSH. And then local. Yeah, maybe that's it. And then okay. TechX server system maybe. Nope. Access list, alias supply. Yeah, I think it's time to get away from what we've been doing here and do something else. Service, maybe that's it. No. I think it's definitely going to be under SSH. And it's definitely public key authentication. But I don't know how to feed in my public key. Okay, here we go. SSH public key authentication. There. See how easy it is? So sometimes it's easy to get. Oh, you know what? Oh, but it doesn't tell me how to. Now, the SSH client is what I'm looking for. Or, no, the server is what I'm looking for. Yeah, okay. Sometimes it's hard to keep straight which is which. I mean, I guess we could add it the other way. We could do show SSH host key. Let's try that. Okay. Let's try that. Okay. Oh, you know what? I can't. Yeah, it's not going to work. Oh, I see. Okay. So. Oh, maybe this is it. So let's get the IP from here. So it's this one. Okay. Oh. Shoot. I'm so confused. Oh, I have to specify the VRF. Okay, yeah, so I can get in this way. but I can't get in the other way. I mean, one thing that's nice is I can get in and look at the key. Okay, so now I've got the key there. So let me try this. Invalid input. That's no good. Oh, maybe I just leave this part out. Oh, was that it? No, I think I got another invalid auth. I mean, we could test it, and I don't think it'll work. I forget which one this is. Usually it's not this hard. Like, why can't I put my key in? I mean, I guess I could set it up temporarily to take a password and then use this copy command. Let me try that. Oh, sorry. No, I know how to do it now. God damn it, I'm stupid. I should have known how to do this. This is just a brain mess up for me. You got to make a user. You always have to make a user. And I forgot to do that. Ah, that's really stupid. I'm sorry for that. I'm sure anyone watching this far is just screaming at the screen. Make a user account, you idiot. It's like basic CCNA, like few months of your CCNA training. Like anyone studying for the CCNA that's been doing it for like more than a month should be like screaming at the screen right now. There's no user account. How dumb is this guy? Very. The answer is very. All right. Aha. So now it goes good. So let's make sure to write it. Write mem, I think it is on this one. And then we can do SSH, and then gposh at and we should get DNS working as well. But for now, let's just make sure that we're good to go. So interface management 10.10.128.116. Oh, what the heck? No. Is the public key not correct? Huh, I don't get that because it's just saying that like maybe I spelled things wrong. Let's take a look. So this is good. We don't want password. I think this might be a problem. Let's get rid of that. I don't know. We might need that. I'm actually not sure. Where is the... Yeah, it looks like the user config somehow didn't make it on there. Okay, so now we got to enter in my authorized key. Oh. Oh, I have to create the user first. And I have to add it to a group. I'll add it to the administrators group. Yes, no password, please. And that now, okay, now it'll work. Perfect. Ugh. What a disaster. Oh, it says it's an invalid input. Oh, no, it's user gposh and then authorized key. There we go. Aha! So, okay, we got it. Yes, I'm invincible! Hopefully people know where that reference is from. So let's write it there. Everything's good to go. Yeah, so we're almost there. We do need DNS. I kind of want to put that on there first because that'll just make this easier. So I think the next thing I want to do is set up DNS on the network. So let's open this here, and then let's say DNSD. Okay, so let's say to the AI. All right. Help me set up this device to be a DNS server.
Setting up a DNS server on Ubuntu 18. 04 can be done using Bind, Berkeley Internet Name Domain, which is a widely used DNS server software. Here are the steps you can follow to set up Bind as a DNS server. Update your system.
Oh, shoot.
Before installing any new software, it's always a good idea to update the package list for upgrades and new package installations. sh copy code sudo apt update sudo apt upgrade install bind. Next, install the bind 9 package along with its utilities. sh copy code sudo apt install bind 9 utils bind 9 doc configure bind. After the installation, you need to configure bind. The main configuration file is located, etc. Bind named. Conference. You might want to configure the following files as well. Etc. by named. Conference. Options, etc. by named. Conference. Local, etc. by named. Conference. Default zones. Here is an example of how you can configure a primary zone in the name. Conference. Local file. sh copy code sudo nano, etc. by named. Conference. Local. Add the following configuration to the file. Replace example. Com with your actual domain name and ns1. Example. Com with your DNS server's fully qualified domain name, FQDN. sh copy code zone example. Com, type master, file, etc. bind per decibel. Example. Com, save and close the file. Create zone files.
Shoot, this is annoying. Let's see here. So, I guess I need do I really need to, how can I verify if a DNS server is already available on my machine? I'm concerned that I won't be able to access the internet.
A DNS server is available on your Ubuntu machine, and that it's correctly resolving domain names. You can follow these steps. 1. Check the resolver configuration. Etc. Resolve. Conference file is used to configure the DNS resolver for the system and will contain the IP addresses of the DNS servers available to the system. Look for lines starting with name server. These lines will list the IP addresses of DNS servers that your system is configured to use. 2. Test DNS resolution. Use the nslookup or dig command to create a domain name and see if it resolves correctly. Or if you receive a non-error response that includes the IP address S associated with the domain name, then DNS resolution is working correctly. 3. Check connectivity. Ping a well-known domain name to check if your machine can reach the internet.
No, I'm telling you. God damn it.
It appears that the nslookup and dig commands are not available on your system, and etc.
No,
resolve.
what I'm telling you. No, what I'm telling you is that my device is that my DNS server cannot be connected to the public internet to use a package manager like apt.
If, etc. resolve. Conference is empty. You can temporarily add a public DNS server dead. sh copy code name server 8 sudo t, etc. resolve. Conference after adding the public DNS server. Try to update the package list and install the
you don't
MCU.
understand. No, you don't understand. This machine will not have internet access. If there's no capacity for it to be a DNS server unless it can access the public internet, then I need to use something else. How can I check the existing tools on this server to see if DNS is one of them?
Server won't have access to the internet and you are looking to utilize pre-installed software to set it up as a DNS
Right,
server. You can check for the presence of common DNS server software and their configurations.
Yes.
Bind, DNS mask, and Unbound are examples of such software. Here are the steps to check if these tools are already installed. 1. Check for Bind. Bind is a widely used DNS server software. You can check if it is installed with, or check if the Bind service is running. 2. Check for DNS mask. DNS mask is another DNS server software, often used for simpler setups or in conjunction with DHCP. Check if it's installed. Check if the DNS mask service is running. 3. Check for Unbound. Unbound is a validating, recursive, and caching DNS resolver. Check if it's installed. Check if the Unbound service is running. 4. Check listening ports. If you are unsure of which DNS server software might be installed, you can check for any services listening on the standard DNS port 53. Or 5. Check installed packages. Another way to check for installed DNS server software is by querying the package manager for all installed packages and filtering the results. If any of these tools are installed and configured, your machine might be capable of functioning as a DNS server without needing internet access. If these tools aren't installed and you don't have access to the internet on this machine, you would typically need to manually download and transfer the installation packages from another machine with internet access. However, since your server is isolated from the internet, you would only be able to resolve local domain names that are manually configured on your DNS server.
Okay, thank you. Yeah, I don't have any of these. Okay, so I have to give it internet access. Alright, well that's fine.
It seems like the machine doesn't have the common DNS server tools, bind, DNS mask, unbound, installed, and even some common commands and utilities like systemcdl and sudo are not found. This could indicate a minimal or specialized installation of Ubuntu. Given the constraints, here are a few alternatives and checks you can consider. 1. Check other DNS software. While the common DNS server software isn't present, there might be less common ones installed. Check for any DNS software by listing all installed packages. Review the list of installed packages for any DNS server software. 2. Check running processes. You can check the currently running processes to see if there's any DNS server software running. Look for any process that might be a DNS server. 3. Check listening ports. Since sudo and netstack commands are not found, you can try using the ss command without sudo to check for services listening on port 53. If something is listening on port 53, it might be a DNS server. 4. Manual installation. If you don't find any DNS software and the machine doesn't have internet access, you would need to manually install DNS server software.
And you have to
downloading
do
the necessary
this.
package files from a machine with internet access, transferring them to this machine, and installing them with dpkg. 5. Use a different machine. If installing DNS server software on this machine is not feasible, consider using a different machine that either already has DNS server software installed or can be connected to the internet to download and install the necessary software. 6. Investigate purpose of machine. Given the hostname OOBZTP DHCP DNS, it seems like this machine might be intended for out-of-band management, zero-touch provisioning, DHCP, and DNS. If it's part of a larger network or system, it might be worth investigating further to understand its intended role and configuration. There might be specific software configurations already in place for these purposes. 7. Consult documentation or support. If this machine is part of a larger system or network, there might be documentation or support resources available that can provide more information on setting up DNS services on this machine.
Oh shoot, it's too long. Okay, well that's fine. We'll just do this. Output. I mean I can cancel it, right? Oh. See, I wish you could just like I wish it would fail more gracefully. Do I have a DNS server installed? It's still too long. Let me grab like half of it. So we got like 200 lines. So we'll grab it here. Okay, there we go.
It appears that you have ISC DHCP server installed, which is a DHCP server.
Oh, I meant DNS.
However, I do not see a DNS server such as Bind9 or DNS mask in the list you have provided. So, based on the given information, it seems like you do not have a DNS server installed on your system. If you want to install a DNS server, you can install Bind9 or another DNS server package available for your distribution. You can install Bind9 using the following command. Remember to configure the DNS server according to your needs after installing it. It appears that the provided output is a list of installed packages on a system, likely from a Debian-based Linux distribution such as Ubuntu. Each line represents a package showing its name, version, architecture, AMD64 indicates a 64-bit system, and a brief description. Here are a few noteworthy packages from the list. libmysql client 20. This package contains the MySQL database client library. Nginx, Nginx Common, Nginx Core. These are packages related to Nginx, a web server, which can also be used as a reverse proxy, load balancer, mail proxy, and HTTP cache. OpenSys client.
Oh, god.
Based on the
damn
provided
it.
list of installed packages, there doesn't appear to be a DNS server such as Bind, named DNS mask.
Alright, well let's
or unbound installed on this system.
try to get one.
The list mostly includes libraries, utilities, and some web server related packages. G. Nginx, but no
I mean,
explicit DNS server package is visible in the provided information.
There's a DNS server, I think in yeah, like if we go here and go to new template, next, and then guests. Yeah, there's DNS right here. Okay. All right, we're gonna do it that way. Okay, and we'll name this to DHCP. Oh, DHCP. Okay. We'll name this to OOB DNS. And we'll put these here where they safely belong. Safety click, safety click. Safety clicks are really important because otherwise you will delete things you did not intend to delete, which is bad. Oh, I remember why I had it there, because I'm out of ports. That's okay. Alright, so we got to turn this DNS server on. I mean, that's fine. There's no problem with that. Okay. Okay, I hooked up a DNS server. Tell me how to set it up.
Bash copy code nano, etc. DNS mask. Conference basic DNS setup. For a basic DNS setup, you might want to configure the following. Set the upstream DNS servers that DNS mask should use to resolve domains. Replace 8, 8, 8, 8 and 8. Setting up a DNS server using DNS mask is fairly straightforward. DNS mask is a lightweight DNS forwarder and DHCP server. Here is a step-by-step guide. Edit configuration file. Open the DNS mask configuration file with a text editor. The default location is etc. DNS mask. Conference. Bash copied, nano, etc. DNS mask. Conference basic DNS setup. For a basic DNS setup, you might want to configure the following. Set the upstream DNS servers that DNS mask should use to resolve domains. Replace 8, 8, 8, 8 and 8, 8, 4, 4 with your preferred DNS servers. Copy code server equals 8. Setting up a DNS server using DNS mask is fairly straightforward. DNS mask is a lightweight DNS forwarder and DHCP server. Here is a step-by-step guide. Edit configuration file. Open the DNS mask configuration file with a text editor. The default location is etc. DNS mask. Conference. Bash copy code nano, etc. DNS mask. Conference basic DNS setup. For a basic DNS setup, you might want to configure the following. Set the upstream DNS servers that DNS mask should use to resolve domains. Replace 8, 8, 8, 8 and 8, 8, 4, 4 with your preferred DNS servers. Copy code server equals 8, 8, 8, 8 server equals 8, 8, 4, 4 specify the interface to listen on. Replace Z0 with the actual interface name on your system. Copy code interface equals Z0 uncommon or add the following line to enable DNS forwarding. Copy code domain needed uncommon or add the following line to prevent DNS mask from forwarding non-routable addresses to the upstream DNS server. Copy code bugus priv restart DNS mask after making the changes. Save the configuration file and restart DNS mask to apply the changes. Bash copy code system ctl restart DNS mask. Test the configuration to test the DNS server. You can use the dig command on the DNS server itself or from another machine, specifying your DNS server as the resolver. Bash copy code dig at less than your DNS server of greater than example. Replace less than your DNS server of greater than with the IP address of your DNS server. Configure client. Finally, don't forget to configure the clients to use the new DNS server by setting their DNS server IP address to the IP address of your DNS mask server. Optional, DHCP setup. If you also want to use DNS mask as a DHCP server, you will need to uncommon and configure the DHCP related options in the etc. DNS mask conference file, such as DHCP range, DHCP option, etc. Remember to review the DNS mask man page, man DNS mask, and the comments in the configuration file for more options and details on how to set up more advanced configurations. Also, make sure to adjust the firewall settings if necessary to allow DNS and DHCP traffic.
I don't know. Where do I just get like var log messages? Um. Uh,
It seems like there may be a bit of confusion in the commands being used. It looks like you're trying to tail the logs but are not specifying a specific file. From your ifconfig output, it looks like your add0 interface does not have an IPv4 address, only an IPv6 one.
oh,
DNS mask can work with IPv6, but for simplicity, I'll assume you're working with IPv4. You might want to ensure that the interface has an
It's not
IPv4
there.
address. For logging, DNS mask logs to the syslog by default, and you can check its logs with. Or, depending on your system configuration, DNS mask logs might be in a different file, such as. This will show you the latest log entries and update in real time as new entries are added. Before proceeding further with DNS mask, please check and confirm if your add0 interface has an IPv4 address assigned, as the configuration and testing would rely on it. If it does not have one, you may need to assign an IP address manually or configure DHCP client settings to obtain one dynamically.
I gave it DHCP, but it's not. It's not drawing from the DHCP server. The DHCP server doesn't even have an IP. Oh, because it doesn't get it from itself. Okay, never mind. I know what's going on. Okay, so we have to give this a static IP. Oops. Yeah, so it has to be static. Okay, so this is going to be at dot 1. I mean, it's not a networking device, so dot 1's kind of not that great. I'm going to call it dot 50, because then we could use dot 1 for if we want to access the out of band network remotely. Then we can do that if we have a networking device at dot 1 and not just this host here. So let's do that. And then we are going to make this dot 50. And we'll make the other one dot 100. Okay, and then this one, I think it's fine if it gets DNS. Shoot. I forget. Oh, right. So we need to cat out this. Oh. Oh, is it because I took it down? Why doesn't ETH0... Why doesn't ETH0 have an IP? I'm very confused right now. I guess I'll ask the AI.
From the given input, it seems like you are trying to configure two servers, OOBDNS and OOBDHCP. These servers are likely supposed to act as a DNS server and a DHCP server, respectively.
Right.
Let's address each server. OOBDNS server for this server. I noticed that you are exploring the file system, but it seems like you're not sure which file log to look into.
Right.
If this server is intended to be a DNS server, you might want to check the configuration files related to DNS, like etc. name, conference, etc. Find name, conference, and the logs related to DNS, which are typically found in var log syslog or var log named. OOBDHCP server. The OOBDHCP server seems to be in the process of being configured as a DHCP server. It appears that you attempted to start the DHCP server, but it failed because it can't open the lease database file var lib DHCP DHCPD. Leases. To solve this issue, you might try creating an empty lease file using the test command and then restarting the DHCP server. Or if you are using a different system service manager. Additionally, I noticed that the ETH0 interface is configured with an IPv4 address, but when you use ifconfig, only an IPv6 address is shown for ETH0. This could mean that the interface is not correctly configured with the IPv4 address. You might want to restart the networking service to apply the changes. Or also, check the DHCP server configuration file, etc. DHCP, DHCPD. Conference to ensure it's correctly configured. For any changes, restart the DHCP server afterward. General notes: be cautious when using ifconfig to bring network interfaces up or down, especially on a remote server, as you may lose connection. For DNS, consider using tools like dig or NS. It appears that your DHCP server is still not starting correctly and that the networking service and systemctl command are not recognized. This suggests that you might be using a system with a different init system or service manager. Given this, let's try a different approach. Check syslog for errors. Since the DHCP server is failing to start, there should be an error message in the syslog. Use the following command to check the last few lines of the syslog. Bash copy code line 20 var log syslog. This should give you more information about why the DHCP server is failing to start. Networking service. Since systemctl and the networking service are not recognized, you might be using a different service manager. Try using the service command to restart the network interface. Bash copy code service network interface restart interface equals ETH0. Replace ETH0 with the interface you are working on if it is different. IPv4 address configuration. Given that the IPv4 address is not showing up with ifconfig, there might be an issue with the configuration and etc. network interfaces. After restarting the network interface, check whether the IPv4 address is correctly assigned with. Bash copy code if config ETH0. If it still doesn't show the IPv4 address, double check the etc. network interfaces file for any syntax errors or misconfiguration. The syslog indicates the root cause of the failure to start the DHCP server. This tells us that there is no subnet declaration for the ETH0 interface in the DHCP configuration file, which is likely, etc. DHCP, DHCPD. Conference. This file needs to have a subnet declaration that matches the network settings of your ETH0 interface, which has been configured with a static IP address of 10. 0. 0. 50 and a subnet mask of 255. 255. 0. 0. Here's what you should do. Edit DHCP configuration file.
Yeah, there
Open,
isn't one.
etc. DHCP, DHCPD. Conference in a text editor.
Where do I put it?
You can use Nano or any other text editor available on your
Oh
system.
no, there's one right here.
Bash copy code Nano, etc. DHCP, DHCPD. Conference add a subnet declaration for the ETH0 interface. Based on your network configuration, it should look something like this. Con copy code subnet 10. 0. 0. 0 net mask 255. 255. The syslog indicates the root cause of the failure to start the DHCP server. This tells us that there is no subnet declaration for the ETH0 interface in the DHCP configuration file, which is likely, etc. DHCP, DHCPD. Conference. This file needs to have a subnet declaration that matches the network settings of your ETH0 interface, which has been configured with a static IP address of 10. 0. 0. It looks like you have added the subnet declaration correctly for the 10.
Yeah,
0.
what the heck?
0. 016 subnet in the DHCP configuration file. This subnet declaration specifies the range of IP addresses that the DHCP server will assign to DHCP
So why
clients.
isn't it?
Additionally, it specifies the default gateway, option routers 10. 0.
I think
0.
it's a GNS
One
thing.
linking face, and the DNS server, option domain name servers 10. 0. 0. One linking face, for the clients. Here are the settings based on your configuration. Subnet, 10. 0, 0, 0 16th IP range for DHCP, 10, 0, 1, 0 to 10, 0, 255, 254 default gateway for clients, 10, 0, 0, 1 DNS server for clients, 10, 0, 0, 1. Given that you have now added the appropriate subnet declaration to your DHCP configuration file, you should try restarting the DHCP server again to see if it starts successfully. Check the syslog for any further error messages if the service does not start. Ensure that there are no typos or syntax errors in the configuration file, as these can prevent the DHCP server from starting successfully. If you continue to face issues or receive error messages, please share any new error messages or further details about your configuration, and I'd be happy to assist further.
Okay, so I'm shutting this down. There we go. It's red, so let's start it back up and see if that works. It should come up pretty fast. Yeah, it's up already. Okay, now we got it. So yeah, I guess we had to restart it for some reason. So it should be good now. Let's see what this is now. This should be getting it from DHCP. We might have to start this one again. I don't want this one to come from DHCP though. I think it will if I stop and restart it, but it's yeah, I wish it didn't. But let me try restarting it. All right, and now let's see if it gets a DHCP address. So yep, it looks like it's doing DHCP. Server's good to go. Oh, it failed to get at least. What a disaster. I mean, it doesn't matter anyway, because it like I don't want it to get a like I want it to be it's better if it's the other one. So I guess I'm gonna do that. Yeah, let me do that. Okay, so I'll set it to 100. Okay, yeah, this is the DNS, the DHCP server's over there, so yep, looks good. And then we'll shut it down and restart it. Okay, looks good to me. Okay, yeah, and it's got that statically configured one, which I want it to have anyway. So let's see if I can ping .50. I can. Okay. All right, so that's a decent network state to stop the video in. We've got the DHCP server up. The DHCP server is handing out leases, as far as I know. So if we do DHCPD, then we get this leases file here, so we can cat that out. There we go. So yeah, we've handed out some leases. We can do a pipe grep on lease, and looks like we've only got it's pipe WC. Hopefully it's building. I don't know what's going on. Or we can do a watch, right? No. can't do it like that. Okay, it looks like there's only 10 being handed out, which is kind of a problem. I'm surprised that's happening. But anyways, yeah, we're in a good state to end the video, and I have to end it anyways. So yeah, we got the DHCP server running. So that's one less thing we have to do in the config we hand off to the techs, and that's something they can get wrong really easily too, especially with the default gateway. So that's a good thing to offload. Then we have the DNS server, which is another good thing to be able to do. So people, you don't have to deal with IPs. Most people that get a job in something like this will know, IP addresses to a good enough level, but it's just nice to say go to this to be able to be more clear with somebody, even like experienced engineers who like know this stuff. And then since it's from DHCP, the IPs might change anyway. So, all right, yeah. So that's the end of this video. When I come back, probably in between videos, I should have SSH established to each of the devices, and then DNS so I can access them through their host names, and we should be able to get into any device without a password, just through the public key from the admin server. And we'll be all set to use Ansible. So exciting things coming soon. Thanks for watching, and see you in the next one.